Hello and welcome to Revision Tips for SIPS Level 6 Professional Diploma in Procurement and Supply. This is Module 8, Innovation in Procurement and Supply, and it's Learning Outcome 2, which is to understand methods to achieve procurement and supply improvements in innovation. So improvements in innovation in procurement and supply share some common characteristics. They can and should include the entire organisation, and both can lead to improved productivity, better quality and enhanced value for money. But there are some differences. Improvement is a management philosophy that looks at the continuality and consistency in making processes, people and products better at what they do. Innovation, on the other hand, means doing something new or different and involves turning an idea into practical reality. The result is something that makes a positive difference to an organisation. Now, there are 5 areas in which technology has the greatest impact for procurement and supply when it comes to controlling expenditure. The process used for gaining control, understanding spend, supplier performance, contract management and compliance, and forecasting and planning. So let's look at these in a bit more detail. So the process used for gaining control. Controlling expenditure is often an important role for a procurement and supply team. It's the process of authorising and recording the use of approved budgets in buying goods and services from third-party suppliers. And we do it in such a way to reduce the risk of fraud, for example. So some of the most common technologies to capture data and control expenditure come from e-procurement, e-sourcing, e-invoicing, all the things we kind of looked at in Learning Outcome 1. So the second, in terms of understanding spend, this is the extent to which a procurement professional can contribute to cost savings that's directly related to their understanding of that spend. So in particular, they'll be able to kind of answer questions like, who buys what? Are they using the most effective suppliers? Are they aggregating spend to increase potential contract size and so get the best available discount? Are there opportunities to respectfully or respecify, should I say, some items so that a buyer can go to market with greater volumes? And are there opportunities to reduce the number of suppliers and so increase the average value of contracts, which in turn leads to better prices? So I guess what you'll do here is have a bit of spend intelligence, which is a system, process and reporting format that provides information and understanding on what is being procured by an organisation. Looking at supplier performance, many organisations rely on the performance of their suppliers in delivery of a quality product or service at the right time and at the agreed cost. If suppliers do not perform well, there will be a knock-on effect to the buying organisation's costs and profits, as well as the reputation. So this means that procurement and supply teams need to monitor and measure the supplier performance continually. And they do this by using a supplier performance management process, or an SPM. And some of the sort of metrics is looking at safety, quality, delivery, cost, morale, and even the environment. Contract management and compliance, with a great deal of effort being put into all organisations creating contracts with suppliers. But less often do we get effort going into the ongoing checking that suppliers are working to the terms of the contract. And without this, there could be additional costs that are incurred because invoices are duplicated or work has to be redone because it didn't meet the standard. And in many industries, there are regulatory requirements that must be adhered to. So it's important to check that suppliers are playing their part in this. And you can carry out a checklist known as contract compliance, which looks at aspects of the contract management and makes sure that the terms of the contract are being followed by the supplier. And then finally, in forecasting and planning, you can forecast in 3 key areas: demand, supply, price, but also inventory management. Now, when it comes to demand forecasting, procurement does not live in a vacuum. The teams buy items to support the production of goods for resale. How much they buy is determined by how much the organisation sells. So this means having a good idea of future sales can help determine how much to buy at any one time. So what you might know this as is the best line of fit, and it's a correlation between the sales figures and the time, and that's also known as a trend line. I mean, other ways that you can do demand forecasting is to consider the use of algorithms or decision trees. We're now going to look at supply forecasting. This is the amount of, I suppose it's the amount you need to buy to support the demand forecast from the previous area that we just talked about. And this is known as dependent forecast because it's dependent on the forecasted value of demand. And the common way of forecasting dependent demand is using an MRP system. And this was developed back in 1964 by Toyota. And what it does is it calculates the materials and components needed to manufacture a product by creating something called a BOM, a bill of materials. And then price forecasting is the understanding of future prices, particularly for the most important things that your organisation buys, because that will help planning and budgeting, but also help to identify items that are likely to have the greatest increase. So the way we can reduce, I suppose, profit and the impact it has on the profit. There are three approaches to forecasting prices. We can do time series forecasting, data mining, and simulation. The time series one looks at techniques using the best line of fit. Data mining involves sorting through large data sets to identify patterns and establish relationships. And the simulation then calculates a number of possible values of the total cost by taking different values of each component based on how frequently they occur in the probability distribution. And so the last bit of forecasting and planning is to do with inventory management, because inventory comprises of the materials, components, sub-assemblies, and other products held in store that can be there to meet the current customer demand. So what it will look at are things like the reorder point, the reorder quantity, and what safety stock they might want to consider holding. Now, data analytics is a set of processes, systems, and technology that allows us to gain insights from the data that we have. The four types of data analytics are descriptive, diagnostic, prescriptive, and predictive. So we're going to look at descriptive analytics, which describes what happened. It's used to provide reports that provide historical insights. So for an example, an organization's sales and finances using visual tools like graphics, tables, and pie charts. It's used to answer questions like, have we spent more on the purchased item this month than last month? Or has the performance of a particular supplier improved or declined in the last quarter? So diagnostic analytics, which is next, gives an insight into why something has happened. So why did a machine break down, or why did spending exceed the planned budget? It's used to identify anomalies and drill down through the data to try and determine why something has happened and the relationship between the cause and the effect. Moving on to predictive analytics. This is forecasting what might happen next. So it could be used to create credit ratings or forecast your inventory levels. It's using analytical tools and techniques to find patterns in data and identify relationships between multiple factors. Then it provides estimates about the probability of a future event. And finally, prescriptive analytics involves and improves decisions about what should be done by helping to find the best course of action to take based on a prediction. So for example, a GPS can suggest a best route to take on traffic conditions. This produces a number of choices together with the probability of their occurrence. And by improving decision making in this way, actions are made more effectively. So let's now move on to data collection and analysing. So, all the approaches that I've discussed already are in fact above. I guess they face a set of problems. How do we collect the data and how do we clean it? And it's estimated that in America, economy loses about $3.1 trillion a year because of poorly managed data. And there are a number of reasons for this. The first one being that it's really time consuming. It estimates that almost 80% of the data scientists' time is taken up cleansing the data set collection sets. It might be because of lack of relevant data. Often an issue for procurement, because many IT systems are set up to facilitate the preparation of financial accounts and the control of budgets. But this means that the codes used to classify spend don't always meet the need of procurement, making it difficult to aggregate data across different products and suppliers. And the next one is fragmentation. The data needs to be effective, and an effective expenditure control can be split across many different platforms and be in many different formats. Some will be in a sort of CSV format, and some might be in unstructured text. And finally, the lack of investment in the tools to extract, cleanse, and analyze the data. So spreadsheets are still the most common way of getting data from systems and then analyzing it. The problem with this is that data may not be held in a common format, and this creates multiple entries that look different but are in fact the same. Now, over the years, procurement and supply has become more and more sophisticated in its approach to enabling organisations to gain an advantage by tapping into their supply chains. So you can see that back in the 1980s, strategic procurement kind of started. They were looking at globalisation and frameworks and the use of ERP systems. But as we move into the 90s and 2000s, we got software that enabled us to do e-procurement, e-auctions, spend cubes, contract management, and catalogues. And at this point, we started to see the establishment of category management and supplier relationship management. And to 2010s and beyond, we're now in this digital era where we have advanced analytics and data-driven optimization, as well as artificial intelligence, downstream procurement activities that are transformed into automation tools, and procurement moves to the center of value creation that's connected with the business. Now, a supply chain is going to be a group of organisations that are brought together collectively to provide goods or services that are required by the end customer. Typical technology applications used in an integrated supply chain will include demand forecasting, inventory simulation, manufacturer planning and scheduling, warehouse management, barcoding and scanning, voice, hardware and speech recognition, some wireless applications, connectivity applications, full automated data flows, worldwide trends and forces that are driving supply chains towards increased integration will include the increased cost competitiveness with diminished returns, shorter product life cycles and faster product development cycles. Whereas globalization and customization of products offering with a higher overall quality. Now, integrating systems between organizations within the supply chain can bring many benefits, such as a better understanding of customers and the requirements of specific segments of that customer base, and allowing products and services to be tailored more closely to what individual customers want, and so increasing sales. A more efficient and streamlined way of working, which is, I suppose, in turn, reducing costs and increasing profits, but also greater flexibility to react to the changes in customer demand and the timing of that demand. You'll also see a reduction in waste and therefore cost in both materials and time, as only what is needed is sourced and used. And vertically integrated supply chains have better control over quality, lower costs to the end user, and raised barriers to entry for new competitors who would need to build the same level of integration to match the incumbent costs. So costs involved in implementing this integrated supply chain is the time involved in training, managing and supporting employees in each of the supply chain links, the cost of the software to enable integration with multiple and often incompatible systems in a different link in the supply chain. Opportunity costs from moving available investment money to supply chain integration from another business. Risks of stoppages in production as the integration gets embedded, or from unforeseen events like a power failure, a storm, or a disruption in communication, and even terrorism and computer hackers. Now, in order to understand how organizations' system integration can improve the knowledge of and information flow to senior managers, you first need to know what tasks and responsibilities those managers have. Now, overall, they're responsible for setting the objective of an organization and designing a strategy to achieve those objectives. So this means providing core responsibilities to senior managers in terms of guidance to people who they directly report to, making sure the priorities and goals are clear, providing requests for investment and managing budgets, overseeing the process for recruitment, motivating and retaining employees, collaborating with their peers in functional areas, and communicating targets and performance against those targets. But there are several stakeholders, and it could be, in large diverse groups of people, there could be quite a few different stakeholders, and also the different businesses, because private sector is clearly about profit, whereas the third sector or the public sector is completely different. But the main stakeholder groups will be the owners of the business, the shareholders who might also be owners. We have the employees, customers, suppliers, and the general public, including the community in which the organisation is based, as well as the government. But in most organisations, the systems that provide information have grown up over the years. And there are major insights now into how a business is working and what opportunities and risks it might be facing, requiring information from different systems to be combined. However, very few, if any, of these systems are capable of talking to each other. And the cost of replacing them with a new system or a set of systems is often prohibitively high. It is this issue that creates the need for system integration. But there are many sources of benefits that have their origins in system integration. So the first one is responding to changing environments. So this will be the first benefit of system integration because it makes it easier to respond to the changes in the environment in which it operates. These changes could come from areas such as competitor activity, customer expectations, or new technology being used in supply markets. So the systems not only allow the senior managers to identify these changes, but also make changes internally so that your organisation can respond to them. We've then got improved productivity. So system integration and improved connectivity can help to improve productivity, as all the information required for reporting or decision-making purposes is instantly available to everybody who needs it. So system integration also reduces the likelihood of errors which can arise when data is moved manually. And then we have improved collaboration, the third benefit that comes from system integration. This is having access to the same data not only allows groups within the organisations to work together more effectively, but it also encourages collaboration up and down supply chains. So a manufacturer, for example, can have a better and earlier access to a customer's requirements, which means that production can be planned more effectively and inventory minimised. In turn, suppliers can access the manufacturer's requirements and plan their own supply and distribution more effectively. And then the fourth and final benefit is the real-time data availability. And integrated systems do allow for that to happen, and they can be accessed throughout the supply chain, meaning that decisions and actions can be taken quickly to achieve a closer match between what customers want and what manufacturers and suppliers can provide. Now, artificial intelligence is a branch of computer science that is directed towards the creation of intelligent machines that can work and react in much the same way as humans. And common uses of artificial intelligence will include problem solving, reasoning, planning, machine learning, speech recognition, and the capability to move and manipulate objects. So machine learning is central to artificial intelligence. It's a method of analysing data and is also used to help automate the building of models of data analysis. The idea behind it is that systems are able to learn by analysing data and finding patterns, and then using those patterns to make decisions. The four most commonly used methods for machine learning are supervised learning. This is where the machine is provided with examples and data from what has happened in the past, together with the results that occurred. These algorithms in the model compare what the model predicts with what actually happened on the future. The unsupervised learning is a method that the machine is not told what the right answer is. So the algorithms in the model are required to evaluate data in order to find interrelationships and determine some structure that the model can use. So for example, it can identify customers with similar attributes who can then be treated similarly in marketing campaigns. Semi-supervised learning, as the name suggests, this method is a combination of supervised and unsupervised learning. It's commonly used where providing completely supervised learning would be a bit too costly. So an early example of this might have been facial recognition on webcams. And then reinforced learning. This is the learning method that interacts with its environment to produce actions and to discover any resulting errors or rewards. But other components that go into making up artificial intelligence include the natural language processing. This is an application of computerization techniques to the analysis and synthesis of large language and speech. So an iPhone, for example, suggests words based on what you've already typed and what you're currently typing. You've got speech to text and text to speech, and as the term suggests, there are algorithms that can convert the written word into the spoken word and vice versa. This was originally aimed at people who were blind to help them read text documents. Expert systems use facts and rules provided by many human experts in a particular field. They help to make decisions and solve problems. An expert system is created by a knowledge engineer, who is a type of programmer. And these systems can be found in medical diagnostic applications or in the design of products like camera lenses and cars. The planning, scheduling and optimization. This involves the allocation of resource to optimize overall performance. And therefore solving this type of problem requires a mixture of planning, scheduling and resource allocation to activities that complete with each order, particularly where there's complex constraints. And then robotics. They're programmable machines that are usually able to carry out a series of actions, either autonomously or semi-autonomously. Image recognition and machine vision is where a machine processes raw material or visual impact, such as a JPEG file, but it's using machine vision to understand what it's seeing. Now, think of computer vision as part of the human brain that processes the information received by the eyes, not the eyes themselves. So it gives the ability to interpret the input it receives through computer vision and categorizes what it sees. So some of the applications of artificial intelligence came from like deep learning, robotic process automation, physical robots, rule-based systems, statistical machine learning, and the natural language progressing and integration. Now, quality inspection is a physical inspection of the product or service against a specification using predefined checklist. This can happen at 3 stages. Firstly, at pre-production. So at this stage, raw materials and components that will be used to make the product are inspected. Finding defects at this stage prevents most costly errors being found after production when the finished product is inspected. The second is in production. This takes place during the construction or production stage, but before manufacture has been completed. So it occurs once 20 to 60% of the product has been completed. And then the third being post-production or final inspection. This is the most common type of inspection. It takes place after the product has been completed and before it is shipped to the customer. And defects found at this stage are really the costliest to rectify and may even lead to the product being scrapped and a new one being made. So the approaches to quality include inspection, detecting errors that can be corrected. Quality control, the checks are performed by trained people, inspectors, to ensure that the quality standards are being achieved. If a difference is found, corrective action can be taken to eliminate the source of the variation. This is applied to the manufacturing of products and services. And then quality assurance checks are carried out by the production and service delivery team to ensure that things are right first time rather than finding defects and correcting them. So that will include making sure that processes are capable of delivering a quality product and checking to make sure those processes work properly. This process is often referred to as zero defects. And total quality management, whereas quality assurance aims to stabilise and control the processes that deliver quality, TQM aims to improve them. Standards for TQM are based on 7 quality management principles. Customer focus, which is the design of products or services that start with a deep understanding of the need of the customer. Leadership, TQM as an organisational wide initiative needs the commitment, support and involvement of the senior managers. Engagement of people, so everyone involved in the process needs to have the right training and education in TQM principles and practice together with personalised development plans. Process approach. The aim of TQM is to get things right first time. So everyone needs access to documentation and other support tools to enable them to understand the part they play in the process and how to carry out the tasks. Improvement. All organisations use processes to meet their objective and focus on TQM as a continuous improvement of these processes. Evidence-based decision-making. Actions and decisions must be made on the basis of fact and not opinion. And relationship management is the final quality. TQM needs teams to work together in a collaborative way for success. This needs management to foster, nurture good relationships within and between teams, both inside their own organisation with suppliers and customers. So what you can see here is the costs of total quality management. And the total cost of quality include both costs of good quality and bad quality. So some of it comes as part of your quality assurance process, some of it comes as part of your quality control process. So on the costs of good quality, you've got the prevention costs, which take action to prevent or reduce defects, like customer surveys and field trials and supplier reviews. The appraisal costs are incurred when products or services are tested against the pre-agreed quality requirements. So any equipment used to measure performance, inspections, testing, carrying out audits and monitoring processes. And on the right-hand side, you've got the cost of poor quality, which can either be internal or external. The internal ones obviously involve you detecting and discovering the error before it's shipped to the customer, but there are still costs involved in the rework and rectification or the scrap of the materials. The external failure cost is actually now it's been received by the customer. You'll end up with complaints and warranty claims and cost of lost sales and product recalls. But on the right-hand side, it's basically showing you, at what point do you spend all your money on preventing the failure or spend all your money on inspecting and correcting? And the honest answer is the point where both of these costs are at the absolute minimum. So where that one dips, the total cost of quality dips, that's the percentage of conformance to the specification you should be aiming for. Now, statistical analysis is the science of collecting and analysing large amounts of data in order to find any underlying patterns or relationships that can be used to make better decisions. The following are examples of its use. Manufacturing. They use statistics to analyse and identify potential improvements in their production methods and to ensure that finished products meet customer expectations and safety requirements. Health organisations will also use statistics to ensure that medicines and vaccines are produced to the same standard and to a high level of consistency so that people are kept healthy. Governments use statistics to better understand their people and their economies so they can provide the services that they need. But the 5 common approaches to statistical analysis look at statistical programming, which uses computer programs to analyse very large amounts of data. There's econometrics, which applies statistical approaches such as frequency distributions and probability distributions, correlation analysis and simulation equation models, as well as time series analysis to large amounts of economic data to test a hypotheses. The next is operations research, which is an application of statistical methods in decision making. It has 3 elements: simulation, optimization, probability, and statistics. And then statistical visualization is the presentation of data in a visual format like a histogram, which is what you can see on the screen. This allows people to discover patterns and relationships that might be hidden in an original data or masked by other statistical treatments. So statistical quality management, it uses commonly used statistics to identify problems with a process so it can be corrected before it becomes a bigger problem. It's closely linked to total quality management, and it's used in lots of goods and service industries. And statistical process control, or SPC, uses 3 stages. It identifies problems by using flowcharts to communicate the flow of processes and constraints. And a Pareto analysis can help to identify where most of the problems occur. Then you identify the root cause of the problem using Ishikawa's diagrams, I'll show you on the next slide, and monitor the key processes to ensure that processes continue to run at the required level of accuracy. So here is an example of Ishikawa's fishbone diagram, sometimes known as the cause and effect diagram. So this links to the statistical process control. So we're at stage 2 of identifying the cause of the problem. So this explores the root cause. It could be the equipment, the ground crew, the flight crew, the environment, the processes, the manpower, the people, the machines. You know, without knowing what actually caused the error, you can't fix it, and the problem will continue to repeat itself. Now, just-in-time is a methodology that acquires or produces materials and components just before they are needed for manufacture of a product or a sale to a customer. In this way, customer demand is met with reduced inventories as a company is only making what is needed when it is needed. So it's widely used in manufacturing organisation and has been a significant contributor to waste minimisation. It was described by Henry Ford in 1923 as we have found a buying material that is not worthwhile to buy for any other immediate need. We buy only enough to fit into the plan of production, taking into consideration the state of the transport at the time. If transport were perfect and an even flow of materials was assured, it would not be necessary to carry any stock whatsoever. And the carloads of raw materials would arrive on schedule and in the planned order and amounts, and go from railway cars to production. That would save a great deal of money for what we use it for in a rapid turnover and decrease the amount of money tied up in stock. And then following World War II, Tashio Ono adapted the JIT system for Toyota in Japan and used it with smaller batch sizes with greater variety of parts that could be made and used on assemblies. So working on the JIT system started in 1952, and the Kanban pull system was developed in 1962. This was at the beginning of the production Toyota system. The word can means visual and ban means card. So Kanban refers to visual cards. It basically tells you when the first bin is empty, it's sort of signaling to you that you need to do something about it. Now, the concept of lean thinking is to maximize customer value while minimizing waste. In other words, lean means creating more value to customers with fewer resources. One conception about lean thinking is that it's only applicable to manufacturing companies, and probably because it was first developed as part of the Toyota production system. But lean thinking has also been applied to many service industries, particularly healthcare and government. So the characteristics of a lean organization and supply chain is that it needs to have a purpose, people, and process. And Womack and Jones proposed 5 steps for achieving lean. Firstly, identify the value. The customer is at the heart of the value and the lean thinking, so it always is expressed in terms of things that are important to the customer, like the functionality, the price, the usability, the reliability of the product or the service. The next is to kind of map the value stream. So once the value has been determined, the next step is to work out all the activities and processes for delivering that value. And this extends from the initial raw material to the delivery of the final product. And it's important to note that a value stream map is not the same as a process map. It doesn't map every possible route and activity in a process for all products, but instead it chooses products or services that contribute the most value to the customer. The third is to create the flow. So at this stage, you're creating a process flow, examining the steps in the value stream that remain after waste has been eliminated to make sure that products flow easily and quickly between variables. Then you establish the pool. Once the flow has been improved, products and services can now move quickly from raw material stage to delivery to the customer. One consequence of this is that products that can be made and services delivered will be much more closely to the time when they're needed. And the final bit is to seek perfection. Lean thinking is not a one-time event, but a continuous process that's captured in the final stage, which is the final seeking of perfection, creating a philosophy within an organization for continuous improvement that involves all employees. Some argue that a process is not truly lean until it has been through the cycle of value stream mapping. But lean thinking approach can be applied to the entire supply chain. The main areas of focus are the suppliers. You need to determine with your peers whether or not to include a requirement in contracts and major suppliers to employ a lean approach in their own organization if they don't already do so. And then in procurement, the second area of the supply chain that can benefit from lean thinking is that procurement. Many teams have embarked on programs that deliver lean thinking results, even if lean is not the original intention. And the most common areas of introduction were things like e-procurement and reverse auctions. And then moving into the manufacturing, this is the next stage of the process flow. So manufacturing looks back at the system integration. Then the warehousing. Following manufacturing, should I say, comes warehousing. And lean thinking for this means taking steps that eliminate waste in product storage, such as receiving goods, activities that put them into storage, picking, packing, and preparing the goods for shipment. And then onto transport. After warehousing comes transport in the value stream. Typical areas that can be improved by lean thinking will include the admin processes, combining orders, cross-docking, import and export processes, and scheduling trucks to pick up goods after they've been delivered to customers. And the final bit is the customers. With any management technique or approach, the customer should always be at the heart of your requirements. And this is certainly true of the efforts in lean supply chains. Customers can be an invaluable source of information about what needs to be improved by providing insights into what constitutes customer satisfaction. And in this case, you solve the problem that the customer is facing. Now, business process reengineering aims to get to the root of why and how things happen the way that they do. It should result in dramatic changes to deliver improvements in measuring performance like cost, quality, service, and speed. Now, reoccurring reengineering themes include combining several jobs into one to eliminate waste, workers making decisions to remove waste or carrying out process steps in natural order rather than strictly sequencing to reduce the end-to-end time taken, or having multiple versions of processes, each aimed at different needs and work performed where it makes most sense. Now, the next is to sort of reduce checks and controls and identify a single point of contact for customers. Or you could use the use of hybrid centralized, decentralized options, which allows teams accountability while benefiting from the economies of scale. So some of the benefits of business process reengineering is that the customer, again, is at the heart of what we do. And that helps an organization to focus on what the customers value the most. An effective business process reengineering implementation should produce a major reduction in costs, which can give an organization a competitive advantage. And employees are typically encouraged to think strategically and question why, not only what is done, but why it's done, which then leads to a more significant result. It helps to break down functional barriers in an organization by forcing employees to focus on the overall process that deliver customer value and not just improve it in their own department. So the key points to note is that business process reengineering is about redesigning processes, whereas lean thinking is more about what currently exists and eliminating waste. This means the two approaches are complementary rather than competing with one another. If an organization just automates processes rather than re-engineering them, it can result in job losses, which threaten employee security. Now, ERP is a common collection of systems and software that many organizations use. And they include things like finance, accounting, procurement, manufacturing, HR, and even warehousing and distribution. The system is cross-functional, connecting different parts of the business together by allowing data to flow easily between them. It does this by collecting data from multiple sources and making it available when the organization needs it. Now, Oracle described the evolution of ERP from its beginning in 1913, when an engineer called Ford Whittam Harris developed what became known as the economic order quantity. And this developed into a paper-based manufacturing system of production, scheduling, and became a standard for many organizations. And in 1964, Black & Decker developed a new model called MRP, which combines the EOQ concept with a mainframe computer. And this has basically just grown rapidly over the years, and technology has continued to evolve. And it's now kind of internet functionality with analytics. And having, an ERP system on a company's premises allows them to keep pace with the modern security demands. But I think it's just worth pointing out that, implementing an ERP system is expensive, but it does integrate your financial information, reduce errors, increase your speed, providing insights into the customer information. It's a standard system that can be used by all employees, which improves the agility, lowers the risk, and provides faster reporting and better collaboration. And I guess the benefits overall is better decision-making ability and enhanced security. But you must be aware of the fact that there are hidden costs, such as business process change and data migration, the custom code, and the change management element. A database is an organized collection of data, which means distinct pieces of information. In more specific terms, a database is an electronic system that allows data to be easily accessed, manipulated, and updated. But it does mean it's a means of kind of sorting and managing and retrieving information. And most use sort of modern database nowadays. And that makes information it collects much more accessible to more people. So they're basically large numbers of records stored efficiently without taking up too much space. It allows for information to be collected quickly and easily and new data to be added to the old data. It can be easily searched, and the processing power makes it easy to manipulate data. It's versatile and can be used for many purposes, as well as being exported or imported. And multiple individuals can access the same data at the same time, but it must be secure in a database rather than a paper file. So some of the characteristics is you've got a self-describing system, program data independence, people have different views, concurrency control, avoiding data redundancy, and making sure you've got the relevant restrictions in place, and the backup and recovery to make sure that if a system does fail, you'd be able to go back to the point before the failure occurred. So some of the types of databases could be sort of personal databases, centralized or decentralized databases, distributed databases or commercial databases, relational, NoSQL databases, operational ones, cloud ones, and even graphic ones. Now, business continuity is the ability for an organisation to maintain essential functions during a disaster as well as after the disaster has occurred. And all businesses should develop and plan to cope with unexpected events and then implement a process of business continuity. Without business continuity, management of a disaster would be really, really difficult. And some of the kind of results that you have from not having a business continuity plan is like loss of facilities and loss of businesses to competition or reputational damage, health and safety liabilities, insurance or people-related problems. So the first step is creating a business continuity plan and identify the potential risks. The way of doing this is to draw a picture of your key supply chains and all the suppliers at different levels. The risks are a number of different forms that happen, but are kind of broad in terms of classifications. Like we might lose access to our facilities and our plants, distribution centres, offices, and all these kinds of things can, be unavailable to us. We could have disruption to our organisation, such as labour strikes or the unavailability of materials. A technology disruption, like a network failure or a cyber attack or a software malfunction. And then organisational risks can include bankruptcy to meet the obligations imposed by regulators. Okay, so the purpose of competitive bidding is to stimulate competition, prevent favouritism, and secure the best goods and services at the lowest possible price that benefit the buying organisation. So the procurement and supply function can encourage innovation at various stages. Like in the first instance, the format of the specification has a large bearing on the market's ability to make improvements or innovate. It can encourage or limit innovation at this stage. But when notifying the market, suppliers can be sought who have a track record of making improvements and delivering innovation. So research on your supply markets in that related field can really help to reveal innovative options. At the pre-qualification stage, questions in the PQQ can be used to find out about the supplier's capabilities to make improvements and to innovate. And then the invitation to tender stage, suppliers are asked to explain how they will meet the needs of the buying organisation. And that could focus on how suppliers will go about improving the current offer and bringing about innovation or implementing continuous improvement. The preferred supplier can be incentivised at the contract award stage by incorporating a gain share pricing mechanism. And there are 4 variants in common use. You have gain share based on the supplier achieving a level of performance over and above what would be expected in normal conditions. The buyer and seller share the savings. Or there's incentivised based pricing, which is a little bit less common. This ties the price to the achievement of an agreed level, often used in conjunction with other forms of pricing such as fixed price or time and materials. Consumption-based risk pricing is based on the amount of services that are consumed. And then the shared risk reward means suppliers share with the buyer any investment needed to develop new products and services, but then also shares the profit made for them. So when a buying organisation has decided to achieve improvements in innovation by collaborating with its key suppliers, it needs to assess where it currently stands on the journey from having no collaborative partnerships to being one of world class. And the assessment grid designed by Dutch consultants PwC can be used. And it assesses things like the strategy and governance, the process, the structure, the people, the technology, performance management and risk management. And at the heart of collaboration between the buyer and supplier is continuous. And it's a way that products and services are supplied. Now, gaps are being identified about how things currently are and where the partnership wants to be. So start by mapping the goals of the organisation. Then compare the goals to see where the goals support each other. Where do you get a synergy? And which are in competition or where the tension arrows are. And the goals in synergy can be used as part of the process to identify ways to improve. Goals in tension may provide potential conflict and need careful management in the relationship. So now I'm going to look at the Scamper technique. I'm not sure if you've heard of this before in previous models, but the Scamper technique was one that was used for identifying opportunities to innovate. And it's basically talking about, firstly, substitute, which is instead of this, I can do that instead. Or combining. So what about I can bring together this and this to create this? Or adapting, I can adapt this in this way. Or modify, I can modify this. Or put it to another purpose, maybe reusing it in this way. Eliminating it or rearranging it like this so that something else can happen. And in many of the examples that I've covered in this learning outcome, the onus is about being able to deliver continuous improvement and innovation. And it's how much of that is being placed on the supplier, and the ways to incentivize them have also been discussed. But there is another way to incentivize suppliers, or at least complement the incentive chosen. And that is to demonstrate that the buying organisation actively promotes and implements innovations and improvements. Underpinning this link between the behaviours suggests that attitudes that result in those behaviours and values can create the attitudes. So it's the value that represents the standard that the organisation and individuals set for themselves, and the attitude at the point which people take that forward. And it could be on sort of things like modern slavery, equality, sustainability, continuous improvement, innovation, or even codes of conduct. But if suppliers see that a buying organisation exhibits the same values, attitudes, and behaviours as stated in the contract and that are expected of them, they will be encouraged and motivated to be involved in continuous improvement and innovation projects. But if there's a disconnect between the values that are stated and those exhibited by the buyer, then suppliers may take action to avoid engaging properly. So you can see this here on the kind of, you've got very active versus passive, destructive versus constructive, which kind of then gives you the expression of dissatisfaction. So the vertical line in the box differentiates between the buying organisation's views and the horizontal one between the suppliers behaving passively or actively. And that basically creates 4 types of responses. Exit, which is where the supplier sees very little hope in being able to meet the demands of the contract. Voice, which is where the supplier seeks to improve the situation, engage with them, and communication is vital. Loyalty is where the supplier behaves passively and waits to see if the situation corrects itself. Or neglect is where the supplier puts in minimal effort that's needed to fulfill the contract and displays a lack of interest. So the procurement and supply teams play a pivotal role in identifying any mismatch between cultures and values and attitudes between 2 organisations, and should attempt to reconcile differences in order to achieve continuous improvement. So that is the end of Learning Outcome 2. Thank you very much for watching.